Good day to you all. Engineering Practices Laboratory, Group B, Electrical and Electronics Part, Experiment 4, title is Measurement of Electrical Quantities, Voltage, Current, Power, Power Factor and Energy in RLC circuit. These are all the parameters we are going to measure for this experiment 4. Okay, so this is a aim to measure power and power factor in a single phase AC circuit using wattmeter with RLC loading. Okay, we are used in RLC loading, and we are using some meters, voltmeter and wattmeter, and then we are using some formulas. We are going to calculate the power and power factor values. Okay, power factor values for in this experiment. Okay, for in that experiment, these are all the basic components and apparatus we are going to use for in this experiment. So single phase auto transformer, 230 volt range, 1 numbers, and voltmeter 0 to 300 volt. MI means this is a type of voltmeter, moving ion type. 0 to 300 volt is a range, 230 volt 0 to 270 volt is a range, and ammeter 0 to 10 amps is a range, and MI is a type. Okay, so MI is a moving ion type. So moving ion type of meters you use to measure both AC and DC voltage and current. Okay, MC means moving coil. The moving coil used to measure only for DC supply. Okay, DC voltage and current. So moving ion means it will be used to measure both AC and DC current and voltages. Okay, so wattmeter, here lagging power factor wattmeters used 300 volt and 10 amps rating, and RLC load we are going to use for that experiment, and some connecting wires we are going to use in the experiment. So this is a circuit diagram, phase and neutral supply, single phase supply 230 volt 58, single phase AC supply. So through the MCB and fuse we are going to connect an energy meter, single phase energy meter. In a single phase energy meter totally used 4 terminals, having 4 terminals. First 2 terminal is input, another 2 terminal is output. So first 2 terminals, the first point is a phase line and another point is a neutral line. In output side, this second one is a phase output, and this one is a neutral output. That phase is connected to the input of auto transformer, and neutral also connected to the input of auto transformer. So this point is the output of the auto transformer. Okay, output, the red color indications terminals will be there, and output of this one is black color terminals available in auto transformer. Okay, so auto transformer used to vary the input voltages. Okay, and then energy meter is used to measure the energy kilowatt hour. Okay, so how much amount of energy consumed in that RLC load, that values will be measured by using that single phase energy meter. Okay, and that one red color line will be connected into the ammeters. The ammeters is 0 to 10 amps rating. So that ammeter is used to measure the amps rating for in this circuit, and voltmeter is to measure the voltage rating for in that circuit. So this is a lagging power factor wattmeter. That wattmeter is used to measure the watts rating. Okay, ammeter negative point 10 amps point will be connected into the M point of wattmeter, and the MC point will be sorted, and the L point of the wattmeter connected into the RLC load. One red color point available. So L point will be connected into the red point, and V point in a wattmeter 300 voltage point is a 300 voltage rating in wattmeter. So 300 voltage point will be connected into the RLC load, black color point. So that 300 voltage point will be connected into the voltmeter 300 point. That voltmeter 300 point connected into the auto transformer negative point, that black color point. So these are all the circuit diagram and connections explanation for in that experiment. So this is a tabulation. The first one is a load voltage. So we are going to switch on that load means, so how much amount of voltage will be there. We are going to first using that auto transformer, we are going to set the voltage of 220 voltage. Okay, so initially we are going to switch on the load. At the time, how much amount of voltage will be there in a circuit, we are going to use this kind of voltmeter to measure that voltage. That voltage rating will be put here for that cell. Okay, and load current. For that load current, ammeter, we are going to use the ammeter to measure that load current. That load current will be noted down here. Okay, and then observed reading, watts rating. Watts rating, we are going to use that wattmeter to measure the watts rating, and here we are going to note it down. Okay, so actual reading, OR into multiplication factor. For in that wattmeter reading based on that connections, so 2 or 4 that values will be there in the multiplication factor. Here we are going to use for that base connections 4. So here suppose the watts rating is 200 means, so 200 into multiplication factor 4 values. So 200 into 4 means 800. So 800 watts will be here for that rating. Suppose 50 watts means 50 into 400. 50 into 4 means 200 watts will be here, will be noted. Okay, so power factor finally I will explain. So observation timing, we are going to put the time constant 1 minute or 2 minutes time constant value is given for in the table. Suppose we are going to 1 minute means number of revolution. So in 1 minute for in that load condition, on condition, so in the energy meter, in single phase induction type energy meter, one disk will be there. How much rotations that will be disk will be rotated and completed, that point will be taken down and noted here, number of revolutions. So this is energy consumed indicated. So EI is equal to n into 4800. So n is nothing but n is a value of number of rotations. So that value into 4800, that values will be noted here. Okay, so power factor, how we are going to calculate the power factor? So power factor formula cos by is equal to actual power divided by apparent power. So actual power is nothing but, so this value is here actual power. Actual power is equal to observed reading W. So this is observed reading W. Suppose 50 values will be there in wattmeter means, so 50 into multiplication factor 4. So totally 200. So 200 is the actual reading. So this is the actual power 200. And apparent power means VL into IL. So this is a VL values, this is a IL values. So both values will be multiplied and we are going to take down for apparent power. Okay, so power factor means that actual power and then divided by apparent power. One result values will be there, that values will be noted down here. So the power factor value not more than 1, number 1. So power factor values, it's below 1 values means it will be incorrect. If more than 1 values means your readings that and all, it's wrong. Okay, so all the power factor values will be less than 1. Okay, so these are all the calculations and circuit explanations for this experiment. Okay, thank you.
This is a experimental setup of measurement of electrical quantities like voltage, current, power and energy. So these parameters now we are going to measure for this experiment. Okay, so this is an experimental setup. So this experiment we are used one energy meter, single phase energy meter. This is a 750 revolution per second constant meter, and one auto transformer, single phase auto transformer, and one voltmeter and one ammeter. Voltmeter used to measure voltage, ammeter used to measure amps current value, and one wattmeters. Wattmeter used to measure power values, and we have to use one single phase 5 kilowatt resistive load bank, okay, for this experiment. Okay, so experimental setup already we have to connect it. So now we are going to see how the readings will be taken for this experiment. Okay, so in the auto transformer, phase and neutral supply already connected, single phase supply. So now I am going to switch on the supply. So initially all the meters readings are 0 conditions. Okay, so now I am going to change the voltage value by using the auto transformer. So auto transformer used to vary the input voltage, output voltages. Okay, so now we'll gradually increase the output voltage. So I am going to set the voltage of 220 voltage. So for in this scale 150 voltage ratings will be showing in this scale, but we are connected in a 300 voltage range, 300 voltage point we are connected. So we have to take the values of 110 means 220 voltage. Now I am setting for this voltage rating. Okay. So initially all the loads for in off conditions, for in the conditions no power ratings and no arms ratings will be there. Okay. So now I am going to switch on 1 arm load for resistive load. Okay. So switch on the 1 amps resistive load for in these conditions. So watts rating 50 watts it will be consumed, and some gradually nearly 1 amps will be readings showing in a ammeter, and some 1 or 2 voltages will be dropped for in these conditions. So for in this condition load is increased, watts and ohms rating will be increased. At the time the voltage, small amount of voltage will be dropped. So in that energy meter, in 1 amps load conditions means in the energy meters, this is a induction type energy meter, the disc will be rotated. The disc will be rotated. Okay. So now we have to take for this watts and ammeter and voltmeter readings, and also I have to mention the constant value of 1 minute. For in that 1 minute how many rotations for in this disc will be rotated, that point will be noted in our observations. Okay. So now I am going to additionally 1 more arms will be switched on for in this load. Okay. For in this condition again we have to take the reading for in a same manner. Okay. So the watts rating 50 to 100 will be changed, and then ammeters nearly 2 amps will be consumed for in this load conditions, and voltmeter another 1 or 2 voltages will be dropped. For in the energy meters the disc rotations will be in fast compared to previously 1 amps load will be in switch on conditions. Now the 2 amps it will be on switch on condition. For in this condition means the disc, energy meter disc will be rotated in fast. Now for in that case conditions we have to take second reading. For in the third case we have to switch on another 2 amps load. For in that case wattmeter 200 watts will be 100 to 200 will be increased, and then 2 amps to 3.7 to 8 amps increased. Voltage another 3 or 4 voltages will be dropped, and in single phase energy meter the disc will be rotated in fast compared to previously, because the load is increased step by step. For in that case condition, for in that experimental condition we have to know about one conclusion. For load increased means, so watts rating and ohms rating increased, and also energy consumption rating also increased. In voltage rating gradually will be dropped for load increase time. Now I am going to reduce the load. Now 2 amps will be off conditions. For in that case watts and ammeters ratings will be dropped, and voltage also gradually increased, and disc rotation in energy meter disc rotations will be dropped. Another in a load another 1 amps will be dropped, means again watts rating and ohms rating will be dropped, and also in energy meter disc rotation speed also dropped, voltage gradually increased. This is experimental understanding. In a conclusion, the load increased means the watts and ohms rating will be increased, and also energy consumption in energy meter disc rotations will be also increased, voltage rating only dropped. Load decreased means watts rating and ohms rating will be dropped, voltage gradually increased, and energy meter disc rotations speed will be dropped. This is a conclusion of this experiment. Okay. Thank you. 6 నిమిషం వచ్చా బాస్.